Okay, now the last one that we're going to look at for a special case is a difference of two squares. And this one's very unique. Again, you're dealing with two perfect squares. And when I have two perfect squares with subtraction in the middle, those will always factor into what we call conjugate binomials. And conjugate binomials are binomials that have the same terms in each binomial, but the sign in the middle is different. So you'll notice one says a plus b, and the other says a minus b. Again, you could still get this by trying to factor, right? What's my middle term that I'm trying to get if I have just a squared minus b squared, and I would be trying to get a 0 for my middle term, okay? But if you see these and you can recognize them, it just makes them a lot faster to factor. For example, x squared is a perfect square, right? X squared is just x being squared. 16 is a perfect square, right? Because 16 comes from 4 squared. So if I can figure out then what my binomials are for these two, I've got perfect squares on each end, and I've got subtraction right here in the middle. This won't work if there's addition in the middle. If I have two perfect squares with subtraction in the middle, I can still factor this into two binomials. Okay, and my binomials are going to look like this. Again, to make x squared, I have to multiply x times x. I've got a negative 16, so my signs have to be a plus and a minus to get a negative 16. And then to make my middle term come out to be 0, I have to have a positive 4 and a negative 4. That's the only way this is going to factor. Okay, so again, with these special cases, it's just a matter of if you recognize them and you know that something specific is going to happen every time you see this, it just speeds up your process of factoring for you. Okay, it's kind of like having your multiplication facts memorized. All right, so 9x squared minus 49. Let's think about 9x squared and 49. Would those be perfect squares? Okay, and that would be true. 9x squared is the quantity 3x being squared, and 49 is 7 being squared. So if I'm going to make my binomials here, my conjugate binomials, both are going to start with 3x. Both are going to have 7. One will get a plus, and one will get a minus in my binomials. So there are my conjugate binomials. Okay, last example over here, 16x squared. 16x squared is a perfect square. I square 4x, right? 4x times 4x makes 16x squared. I square 1 to make 1. Make my binomials 4x and 4x, because that's what I squared to make 16x squared. 1 and 1, put a plus and a minus, and those are my conjugate binomials. Okay, so the special cases, although they're nice, and if you see them, you can make your factoring go much quicker because you know what's going to happen with them. You can also still reason them out using any of your other methods for factoring.